Alright, probably my favorite part of dealing with radicals would be to solve radical equations. So what we want to do is solve them with one term, one radical term, solve them with two radical terms. A little tough on that one. And then look at some applied problems that involve radicals. Okay, so a couple principles that we need to, or laws that we need to look at right away with these is the principle of powers. The principle of power says, these should be exponents over here. Let me rewrite that. A to the n is equal to bn. Principle of power says that if I have two terms or expressions that are equal to each other, that I can raise one of them to any power I want. I pick n, as long as I raise the other one to the n. And if I raise both of them to the n, then the equality of those two expressions remains. Okay, that's one principle. The other one is called the principle of isolation. I was feeling sorry because I didn't have my own principle, so I made this one up. But what it says is, and it's basically just a tip, you need to make sure when you are dealing with a radical equation that you isolate the radical first. If you isolate it, then you can apply the principle of powers. If you don't isolate it first, then you're going to cause yourself some grief and more work. Okay, so let's try some. We'll try a couple with just one radical in the equation, and then we'll try some with two. Okay, so here I have an equation. Root of x minus 4 is equal to 2. My question at the top says solve for x. So I want to know what number I can plug in for x there that will make this equation true. Well, we said that the first thing that we want to do is isolate the radical. So here's the radical. I want to get it on a side of the equal sign by its lonesome, meaning that this minus 4's got to go. So I'm going to add 4 to both sides, add 4 to both sides. So I'm going to have the square root of x is equal to 2 plus 4, which is 6. Okay, I've isolated that radical. Now I can use the principle of powers, which says that if I raise this side to a certain number, I have to raise this side to a certain number. Since this is a square root, in order to cancel that out, I'm going to square this side. Similarly, if I square this one, the rule says got to square that one. So if I square a square root, these actually cancel. So, and if I want, I could write it as a fractional exponent, but I'm not going to get into that. These two will cancel, leaving me with simply x, and then 6 squared is 36. Oh, I like those kind of questions. Now, it's probably a good idea to check these. Let's just do a check over here. So the square root of x minus 4 is equal to 2. I'm calling the x to be 36. Minus 4 is equal to 2, I'm hoping. Square root of 36 is 6. 6 take away 4 does indeed give me 2. I'm happy with that as my answer. Let's try another one. Oh, a little bit bigger. Okay, so it's a radical equation. I have to solve for x. Gee, I got a couple x's here. Well, let's start with the radical thing. Here I have a radical. It looks like it's isolated. It's on an equal side by itself. So the rule says to get rid of this one, I can square it. Principle of powers. But if I square this side, I have to square the whole other side as well. Okay, when I square this side, all I'll be left with is 2x plus 7. No radical anymore. On this side, don't get tempted to write x squared plus 4 because that's not right. I'd have to write x plus 2 times x plus 2. There's two of them. I'm going to have to FOIL that. X squared plus 2x plus another 2x. That'd be plus 4x plus 4 is equal to 2x plus 7. Okay, I've gotten rid of my radical, but now I'm sort of in tight here. It's not like this last one. Give me one like this one. It's not like that one. Oh, but it's a quadratic. Hey, we know how to deal with quadratics. Let's bring everything over to one side. So the 2x comes over and subtracts. So 4x minus 2x would be 2x. And the 7 comes over and subtracts. So 4 take away 7 would be minus 3 is equal to 0. Here I've got a quadratic. I can factor it. I can use the quadratic formula. Lots of ways of dealing with that. Let's see. I think I can factor it. So x goes here, x goes there. 3 times 1. And then I think the 3 has to be plus and this one minus. Let's just check that. X squared plus 3x minus an x gives me 2x. Minus 1 times 3 gives me minus 3. Yeah, that checks out. Okay, so here I use the principle of powers. Right here, do you remember the name of the property we're going to use to solve this one? The zero property. Very good if you were thinking that. Zero property. Which says that if I have two things that multiply together to get 0, one of them's got to be 0. So x minus 1 is 0, or x plus 3 is equal to 0. Solving this one gives me a 1. Solving this one gives me a minus 3. I'm feeling pretty cool now. I've dealt with a radical up top there. I've used my principle of powers to get rid of it. I've noticed it's a quadratic. I've collected everything. I've factored things. I've used the zero property. I'm feeling pretty good at this point. However, with radicals, it's essential that you take these numbers and plug them back in to ensure that they check out, like we did on the last one. So let's just try that. I'm going to write my check down over on this side. Hopefully the check won't take too much room. Sorry, I should put it below, but I didn't want to lose this. Okay, so I have x plus 2 is equal to the square root of 2x plus 7. I'm calling a 1. So I put a 1 in there. 1 plus 2 is 3. Equals, I put a 1 in there. 2 times 1 is 2. 2 plus 7 is 9. The square root of 9, it comes out to 3 too. Yeah, I'm quite happy with 1. That one checks out. Minus 3, yeah, I don't know. Let's see. Let's do the next check. So I plug a minus 3 in there. Minus 3 plus 2 is a negative 1. Okay, equals. Okay, I have to put a minus 1 in here. So 2 times minus 1. No, I'm putting a minus 3 in. 2 times minus 3 is negative 6. And negative 6 plus 7 is 1. Oh, and the square root of 1 is 1. Square root of 1 is plain old 1. Oh, but on the other side I have a minus 1. Those two don't jive. Therefore, this one I can't have as an answer. This one I can write as doesn't check. Or, if you want, you can take a different color and draw a line through it. Something like that. Just to indicate to your instructor that this is a solution and minus 3 is not a solution. All right, I'd encourage you maybe, oh, do I have another one? Oh, here I have another one. This one's very similar to the one we just did. Very, very similar. Try that. And maybe at this point you can pause and try some of the questions in your textbook. But practice those. Isolate the radicals, square both sides, the principle of powers, and then see if you can simplify it. Always at the end, once you get your answers, check each of your answers to ensure that they both work. Because sometimes both of them won't work and there will be no solution for your question. So be careful with that. All right, let's forge ahead into hitting my printer, into two radicals. When you have two radicals, the one deal with this one is it's just sort of double the work of one where you have one radical. And the trick is to isolate one of the radicals, use the principle of powers, multiply things through, isolate the second radical, do the same thing over. So it's basically what you do. So you isolate one, use the principle of powers, isolate the next, solve, and then check your answers. Let's try this one. I'm going to push this x minus 5 to the other side. So I'm going to say I have square root of x is equal to 1 plus the square root of x minus 5. Just see if that's okay. I took this to the other side, it became positive. Yeah, that's okay. So I've isolated one of these radicals, so now let's get rid of it. So what I'm going to do to this side is I'm going to square this side. But if I square this side, I'm going to have to square this side. Ooh, the distributive property with radicals, right on. Square root of x squared comes out to just x is equal to, let's write this one out. This will be 1 plus root 5. It's squared, so there's another 1 plus root 5 right beside it. Let's do the FOIL thing. 1 times 1 is 1. 1 times root 5 is a plus root 5. Root 5 times 1 is another plus root 5. Root 5 times root 5 is the square root of 25, which is simply 5. Okay, let's do a bit of simplification here. So I have x is equal to 1 plus 5, that's 6. And then root 5 plus root 5 is 2 root 5. Okay, I'm feeling pretty good there. I was able to eliminate one of the radicals. Now I'm just stuck with one radical, which is okay. They say isolate it and then use the principle of powers again. Okay, so I'm going to move the 6 to the other side. So it'll be x minus 6 is equal to 2 root 5. Now in this case, I like to isolate just the radical, but if I wanted to get rid of this 2, I'm going to have to divide both of these by 2. It's going to give me fractions on this side. Be a little bit messy. I'm going to choose not to do that. I'm going to choose simply to, let me write it down on another line. X minus 6 is equal to 2 root 5. I'm just going to square this whole thing, and I'm going to square this whole thing. Either way, it'll work out to the same, but this is just a little bit cleaner. Okay, so principle of powers. So x minus 6 squared, again, I've got x minus 6 times another x minus 6. On this side, 2 squared would be 4. Root 5 times root 5 is just plain 5. Okay, so on this side, I'm going to have x squared minus 6x minus another 6x plus 36 is equal to 4 times 5 is 20. Simplifying, oh, it's a quadratic again. Oh, good. I like doing those. X squared, this would be minus 12x. I have to bring this 20 to the other side and subtract it, so it'll be plus 16 is equal to 0. Okay, that's looking good. And finally now I'm going to have to factor this. Is that 16? Yeah, I think that's right. Okay, so two numbers that multiply to 16, 4 and 4, 8 and 2, 16 and 1. But none of those add up to 12. Oh, goodness. At this point then, since I can't factor this, then to find my solutions, I'm going to have to resort to using the quadratic formula, which we've seen in other lessons. So the quadratic formula says x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Of course, a is 1, b is a negative 12, c is 16. You plug them in and you'll come up with two answers for your solution. This is sort of a nasty question because your answer here isn't going to come out to a nice thing like 2. Because I can't factor that, I'm going to have some kind of radical in my answer. So at the end, if I have to check those radicals up here, it'll make for a little bit of brain power to get all that stuff figured out. Anyway, the key thing that I wanted to show from this question, though, was if there's two radicals, I isolate one, use principle of powers to get rid of it. Then simplify things and then isolate the second radical and then use principle of powers again to get rid of the radical. Once you're rid of the radical, then just deal with what comes up. Sometimes it's a quadratic, sometimes it could be a linear function that you have to solve. Lastly, there are some applications that use radicals. For example, this one, the speed of sound in air, c, in meters per second can be calculated by this here formula, where t is the temperature in Celsius. So if they want me to, in this case here, find the speed of sound if the temperature is 30 degrees Celsius, what I would need to do is plug the 30 in there, 30 plus that, divided by this, take the square root of that, multiply it by this, and that would determine what the speed of sound would be for that particular question. For me, maybe a little bit more interesting question would be if I had the speed of sound to be 3.5 meters per second, what would the temperature have to be? So in that case, I know what C is. It's 3.5 is equal to 331.5 times the square root of T plus 273.15 all over 273.15. And now I have to solve for T. So the first thing I want to do is I want to isolate this radical. So I'll divide both sides by 331. I don't have my calculator with me, so I might just leave this as a decimal, is equal to the square root of T plus 273.15 all over 273.15. I've isolated my radical. Now I'll square both sides. So I'm just going to do it in the same line there. So I'll take this side and square it. I'll take this side and square it. So I'm going to wind up with whatever 3.5 divided by 331.5 squared is equal to this side, T plus 273.15 over 273.15. And now I'm back to a question where I can use the ratio proportion or whatever tools I need to in order to solve for T. Okay, but here I was just showing you that you could isolate that radical, square both sides, and then continue to solve for the question. So solving radicals, quite an interesting question where, and the ones that you'll be faced with will probably be ones where you'd have one radical, so isolate it and then solve, or you might get two radicals like this one, where you isolate the first one, get rid of it, simplify, then isolate the second one and get rid of it, and then solve from there. All right, to those questions.